And then, so Jack will be speaking about red team maturity through code, so automation via writing code and then making your red team operations better.
Yeah.
Yep.
Awesome.
Welcome.
Thank you so much, Cipriana. I really appreciate it. Awesome. Thank you, guys. So thank you all for coming to my talk. My name is Jack. I'm a red teamer with a passion for infrastructure as code and development. And in 2021, I had the opportunity to red team national CCDC for the first time. CCDC is a red versus blue event where college students defend against professional red teamers. I was really excited to give back to an event I had competed in and learned so much from as a student. I wanted to do my best and make sure that the students had a great experience. So I built a new rootkit. I prepared a lot of backdoors and different C2s so that I would have access and depth and make sure that they had a lot of learning opportunities. But national CCDC is unpredictable. I went in totally blind. There was no idea what the OSs would be, the services, just like a real black box test. The only difference is at national CCDC, you have to compromise the entire environment, 20-something systems, in under 15 minutes. I followed the advice of veteran volunteers and wrote my persistence and recon as bash one-liners. I even tried to make it fault tolerant, so checking which packages are installed, trying to troubleshoot common misconfigurations in line, and testing throughout my lab. I was ready to go fast, copy-pasting my kit onto each VM. My first year was an eye-opening experience, though. Even though I tested everything thoroughly, the scale of the event and the skill of the students really humbled me. After 2021, I felt like there was 4 key problems that apply to real red team engagements. The first problem, reliability. Having 100 plus callbacks a minute is an insane scale, and a lot of C2 frameworks will crash at that scale. One will even crash in an unrecoverable way that you have to re-exploit the box, kill your beacon, and then you can start to regain control of other beacons. This isn't ideal for a real red team engagement, where you don't want to be throwing exploits over and over and over. Second, repeatability. Making sure that everyone has the same learning opportunities during the training event is super important to me. In the real world, this is really helpful for our detection engineers. We want to make sure that they have the opportunity to see things, re-see things as we're bringing new people in, and making sure that we can train and build detections and have test cases to verify those detections are working. Third, onboarding. As a volunteer event, we have a really high turnover rate, so we always have new people coming in. We're always training them up on what we're doing, how we're using specific TTPs, and the unique way we do stuff. In the real world, this is very relevant. Turnover rates across the industry are really high right now, tech being about 2 years between job switches. And then lastly, speed. You want to go really fast. For CCDC, this was really important because you have to get everything within 15 minutes. You just got to go really fast. In real life, you don't want to be sticking around on a box, just kind of puddling around. You want to have a plan, get in, execute, and then get out so that you're not caught. So with these 4 problems in mind, I was looking around trying to figure out, like, has anyone else solved this problem already? So I don't have to reinvent the wheel. I'm super lazy, don't really want to build new things, so if I can avoid it, love reusing other things. And kind of is the answer. Ops teams have had very similar problems for years, and their solution has been, to some extent, infrastructure as code. So defining how we deploy our infrastructure, defining how we do configuration management through code systems. So what if we use infrastructure as code as a C2 framework? So for the last 3 years, I've been using Ansible as a C2 framework, trying to use it to solve these 4 problems. And it kind of works. Right off the bat, we get speed and reliability. Ansible is designed to run across an enterprise, so easy. We have that. Second, repeatability. Ansible allows you to define discrete actions and rerun them either across the entire environment or on discrete parts of it. So if you have a specific host that you need to rerun a TTP on so that someone can see it for detection or needs to relearn how to, like, what that looks like, very easy to do through Ansible. Second, self-documentation. Ansible has very easy to read YAML configuration files, so it's very quick and easy to get through and see exactly what's going on. And then third was kind of a surprise to me, but version control. Being able to actually track over time how your TTPs have changed was a super, super cool benefit that I did not expect to see coming out of this. An example of that here. So this is a different red versus blue event that I've participated in called ISTS, which is hosted by RITSec in Rochester, New York. So I've been red teaming that for the last 3 years, and each year I build an Ansible playbook for it. And on the first year, you can see I came in, not a lot of stuff. Was not really prepared. I didn't really know what I was doing. So I just came in with a couple different things and hoped for the best. The second year, I really learned what worked and what didn't work. And we can see that through the code change, where now we have bind shells that are different protocols. We have C2 frameworks that are doing long and short callbacks, starting to clear the history, adding other backdoors. And then this most recent year, really folding in on diversifying communications. So not only is it different protocols for communication, but different C2s with different protocols with different callback intervals. And I think this is a really cool way that you can measure both your skill as a red teamer and your team's skill as a red teamer, but also what the defenders are forcing you to evolve. Because these are all, like I said, I'm lazy. I would not have done these if I didn't have to. But the students at ISTS really pushed me to up my game, and so each year it's very cool to see how we've had to innovate and change our TTPs. So version control, very cool benefit of using Ansible as a C2 framework. But it's not all great. There's a lot of cons to using Ansible as a C2 framework because it's not really designed to be a C2 framework. First downside, it's really noisy. Ansible, when it logs in, that's a log. When it runs a command, that gets logged to journal. If something fails, it will dump the failure state to disk. Lots and lots of artifacts get left by Ansible as it runs through the system. There's some things you can do to try and hide it or make it a little bit less noisy, but it's a lot of work and you may not catch everything. Second is the requirements. Ansible has a lot of requirements. You need to have a remote management service like WinRM or SSH. And then you also need to have credentials to that service, and that's either a username, password, username or certificate, something like that. And as a red teamer, that's very rarely something I have. So it's usually some gross web exploit or some wild shell that I'm holding on to for dear life, and I don't have the luxury of just logging in. So with that, it was kind of rough. And then lastly, capabilities. Ansible doesn't support a lot of the capabilities we want to emulate as a red team. It's very hard to do like, do the in-memory reading, writing, and execution. Not something Ansible is designed for, very reasonably, but something that as a red team we really want to be able to emulate. So for those three reasons, I haven't been able to use Ansible as a real red team engagement platform. I've only been able to use it through these kind of training exercises where we can mitigate some of those cons. But it got me thinking, how do we merge these two ideas together? How do we have Ansible, how do we have the pros of Ansible, but also get the benefits of a traditional C2 framework? And so for the last 2 years, I've been working on a project called Realm with some of my friends. Realm is a C2 framework with a custom Python interpreter embedded in the agent. This allows you to define your TTPs as code and execute them in the agent. Realm prioritizes automation, reliability and scaling, and logging. First off, logging. The who, what, when, where, why. Using our graph backend, we track every action that's taken, who it was taken by using their SSO ID, when it was run, and then what it ran against. We also track things like the start time, last updated time, and finish time so that you're very aware of when execution started on the host and execution finished on the host. Next, reliability and scaling. Realm uses a stateless C2 server, which means that none of the actual data for the C2 is stored inside the app itself. It's stored in a database on the back end. This allows us to scale it horizontally really easily, either all within the same region or provider, or different regions, different providers, and we can scale to meet the need of whatever the callback rate is. Database as a service backend. Having a managed database, really nice. Prevents us from having to manage OS updates, prevents us from having to do service updates. Everything is managed by the cloud hosting service, and it helps scale as well because we can just say, hey, have more resources. We don't have to go in and resize any disks. We don't have to resize any VMs. We just say, give it more. And then lastly, CI/CD. From the start of the project, we've really heavily leveraged testing throughout our development cycle. So every time we build a new feature, we're building tests for it. We're building out tests whenever we find bugs to make sure that we're catching them and not reintroducing them. And that has been really, really helpful for, one, development speed, but also just being confident that what we're putting out is actually doing what we think it is and defining that behavior very specifically. Here's a picture of our code coverage, which I'm very proud of. Our implant coverage is really high, which I think is important, just because that's exactly what's going out on the client, the victim host. We want to make sure that that's really reliable and not going to cause issues for them since we're a guest, even though we're doing bad things. Then lastly, automation. This is what really sets Realm apart from other C2 frameworks. The built-in interpreter. So every agent has the built-in interpreter called Eldritch embedded in it. And this allows you to find complex TTPs within the language and then have them get executed in memory on the agent. Another fun part of this is that you can take those TTPs that you've used in an engagement and an operation and you can export them, compile them into the standalone interpreter and hand them to detection engineering, and then they have atomic test cases for that specific TTP. So it really helps reduce the cycle between, hey, we did this thing, build detection around it, to, and then having to rerun stuff or teach them how to rerun stuff to, okay, well, export it and hand you the binary. The GraphQL API has been super awesome to work with. It's really powerful in tracking everything that we're working with and trying to create context around things. One of the things that's really nice about it is we're using code generation for the server and the client. So anytime we update the API, we regenerate the client side too, which helps lock them in step together so there's no API version mismatches. The API also allows for really easy integrations. One of the ones we've done recently was for Pwnboard, which we use as a situational awareness dashboard during training exercises. And then lastly, host tagging. One of the things that gets really confusing when you're doing an engagement with a lot of hosts or a training exercise is, what is this? Where's this beacon live? What's it do? And so being able to tag the host as both the context of what it is and where it lives, it makes it a lot easier to search through and then better understand the context later. Here's our demo. Nice. So, oh, here we go. So this is a demo of creating a tome, which is the interpreter, the interpreted script. First, I'm going ahead and going to copy a template and then start building off of that. Tomes are made up of 3 files. The metadata file, which is what I'm modifying here, and this defines the name of the tome, what it does, and then any input parameters that you can provide to it. And then over here, we're going to actually start jumping into some of the code here in our Eldritch file. Here we are checking which OS the tome is executing on. And we're going to set our home path up there. Sorry, I can't see it on my screen, so I'm like checking back and forth. Yep, and now here we're starting to check and see which OS we're on. We're doing this because Realm runs across Mac OS, Linux, and Windows. So being able to check which host you're at, like what the OS you're on actually is really important as you're doing development here. This tome is going to go ahead and we're going to loop through and grab all of the private SSH keys that are on the box. The way we're going to do this is by first looping through the home dir to enumerate users. Second, we're going to loop through their directory, and we're going to identify folders in that directory, looking for the .ssh folder. Once we find the .ssh folder, we want to look through that, and we want to see if there's any private keys. And we'll check our private keys by the file permissions that they have. Another cool thing about Realm is it supports M2 series ARM, which, nice. All of this is written in Rust, so the agent side is all Rust. We have, that sounds good. The agent, the interpreter, all are Rust, and that's made it very easy to do our cross-platform development along with our cross-architecture development. So really pleased with that so far, as well as keeping our binaries a little bit smaller. Nice, and now we're getting to the end here where we have our SSH keys. We're going to go and grab. Now, this is probably not something you'll want to run in production. There's a couple other things we might want to do and add some checks here, things such as adding support for Windows, checking our root directory, checking if we're running as root, because this does assume that we have root privileges and we can read everyone's home directory, or even embedding files in the agent itself. Nice. Yep, and then so this looks a lot like Python, and that's because that's the intention. This is based off of the Starlark DSL, which is a Python-like interpreter. And so we've gone ahead and taken that and we've expanded it with these very like red team specific functionality like file.list, process list, sysnetstat, or port scanning. Nice. And so there we go. We're able to grab our private keys from every user on that box. So next, let's go ahead. We finished doing our local development. Let's go ahead and run it in prod. Oh. No. Sorry. But we're able to then go ahead and there we go. We can then go ahead and grab that tome that we've developed and tested locally. We can go and code it for JSON so that we can upload it through our API endpoint. This is the GraphQL API that we're working with, where we can go ahead and set the variables for what its name is, the description, and then the actual script that it's going to execute. The API allows us to query a lot of things and go in different levels of querying, which is very nice. There we go. Paste and send. So now we've uploaded a tome to Realm. So we're going to go into the UI and go ahead and task our beacon to execute it. So first we have to create a new quest, and then we have to find our tome. We're going to give it a descriptive name so that later we can go back and understand what we were trying to do. This is really helpful, especially on longer engagements when you're trying to figure out, like, what exactly did we do as we were doing it, or why were we running that specific command? And there we go. Our tome has finished executing, and we have the private keys. Oh, yeah. That's all from me. Does anyone have questions? And that's where you can find Realm. Yeah, question?
It's publicly available and
Yep, it is publicly available on GitHub, spellshift/Realm. Yeah. We haven't tried it out yet. Awesome, guys. Thank you for being a great audience. Have a good ShmooCon.